Good morning, class. We are on to 8.1 Similar Polygons, and our first definition is similar figures. These are three definitions we actually covered last semester, but just as a recap, similar figures are geometric figures that have same shape but not same size. Okay, so another way to think of this is dilation. Cover that in our transformations last semester. So dilation is where we can scale a figure big or small using a scale factor. So just a couple of points to think about for later. Now, similarity transformation. Now, there's three transformations, or really four transformations that we talked about. There was rotation, reflection, translation, and dilation. This particular definition, though, just deals with dilations and then the other transformations. So, in definition terms, I have dilations, or a composition. And composition is like another word for combination of rigid motions and dilations. So, for example, this is where you take a figure, and let's say I had a triangle, and let's say I wanted to reflect it, so I flipped it upside down, and then I scaled it bigger. So it can be any combination of these. For example, I could go backwards. As long as dilation is definitely included, then it's considered a similarity transformation. Okay? And then we'll talk about corresponding parts, and that is pairs of sides and angles that have the same relative position in two congruent figures. Okay, so pairs of sides and angles that have the same relative position in two congruent figures. So we kind of covered that one before, but we're going to go down to our core concepts. And so this is how we're pertaining corresponding parts with ratios that we did last time. So we have corresponding angles, and these will always be the same. Angles will stay the same. And angles are same. Okay, but now we have ratios to the corresponding sides. Note that our big one, so DE, is congruent to AB, and our scale factor, which got bigger, is on top. Okay, and K is our scale factor, or another word for scale factor. Okay, so let's do an example. I'm going to draw two triangles. I'm going to ask myself three questions on these. So the first one is, what is the scale factor between these two similar figures? The second one is, I want to name the congruent angles. And the third question is writing a statement of proportionality. So statement of proportionality. Okay? And a statement of proportionality looks very similar to this. Alright, so I have my two triangles. And so let's compare our angles, shall we? So let's go on number 2. We can recognize congruent angles. So what is congruent to A? So the congruent to A would be J. what's congruent to B would be K, and what's congruent to C would be angle L. Okay, so corresponding angles. Okay, and now let's go ahead and try to figure out our scale factor and our statement of proportionality. These are going to relate very similar to each other. So what's congruent to BA? BA would be KJ. So we're actually going to do what this one says, and they put the scale factor that's pretty much bigger on top. So we have KJ is over AB. Okay? And KJ is 36, and AB is 27. So we're going to reduce it momentarily. Let's just compare out the rest of them. So then let's look at KL. So KL is congruent to BC. And KL is 48, and BC is 36. Okay, and our last one, we have JL, and then we have AC, which is the same as 28 over 21. And so now I'm going to find my scale factor. And another way to find the scale factor is by reducing. So if I were to type this into my calculator, so our first one was 36 over 27. So I have 36 divided by 27. I end up with a really large decimal. Now in this case, we really want a fraction. So we're going to hit Math. Make sure it's selected on fraction. You're going to press Enter twice at the bottom, and you get 4/3. Okay, now let's try the next one. So 48 divided by 36. I still end up with that long decimal, but I want a fraction. So I get 4/3 again. And I bet if we were to type the last one, we'd still get 4/3. But let's double check. So I have 28 divided by 21. Long decimal. And I hit fraction. And I get 4/3. So my scale factor is 4/3. Okay? Now our statement of proportionality is written just like this. Now we're just knowing that they're all equal to each other based on the scale factor. So we have KJ over AB is equal to KL over BC, which is equal to JL all over AC. And that's our statement of proportionality. And note, they can be written in a different order. I could have put this one first. It doesn't really matter because they all have the same scale factor. Okay, moving on to the next page. Now you are more than welcome to pause at any moment if there is something that you did not get a chance to write. Okay, so I have corresponding lengths in similar polygons. And so if two polygons are similar, then the ratio of the two corresponding lengths is equal to the scale factor of the similar polygons. And so I'm going to demonstrate this by using a couple of examples. And this one I'm going to use where we solve for x. So I still have two triangles. Call the small one DEF, where I have x, 20, and 15. And our bigger one is going to be MP. And MP is 24, and N is 18. And the hypotenuse, assuming it's a right triangle, is 30. Okay? So let's compare our matching sides. So let's see what's congruent to NP. Well, that would be EF. And that's what our missing side is. But I know the rest of them, I have MP is congruent to DF. And then I have NM is congruent to ED. Note, hopefully, that all these are congruent. But let's solve for x first. So let's do with these two. So I have NP is 30. And EF is x. That's what I'm trying to solve for. I have MP is 24, and then I have DF is 20. Okay, so what I'm going to do is I'm going to cross multiply, and I end up with x equaling 25. Remember the butterfly effect. So I end up with x being 25. So now let's compare our ratios. So I have 24 over 20. So 24 over 20, remember if we were to type it into our calculator, this is another way of reducing. I still have a 1.5, but if I hit math, enter, enter, I end up with 6 over 5. Okay, and let's check the other two. And then I have MP over DF. That was what MP over DF was. So let's check the other one. I have NM over ED, and that's the same as 18 over 15. So 18 over 15. I still end up with 1.5, which is the same as 6 over 5. And we can double check our answer where we have 30 over 25. So 30 divided by 25, a fraction, and I still end up with 6 over 5. So I've checked my answer. My scale factors were the same after I plugged in x. Okay? So moving on to the perimeters of similar polygons. So now they're saying that the ratio of the perimeters is equal to the ratio of corresponding lengths. So the perimeter or P scale factor is same as lengths. So the scale factor should be the same if I wanted to compare the perimeter. So the best way to show this is always by doing the example, always with practice, practice, practice. So this time I'm going to draw two rectangles, and I have lengths of 6 and 15, and then I have x and 35. And I want to compare the perimeters, but before I do that, I need to solve for x. So let's draw our ratio, or draw our proportion in order to solve for x. So what is corresponding to 6? Well, that would be x. I have 6 over 15 equal to x over 35. Note that I paired these two together, especially if they're facing the same direction. I like to put a giant equal sign here. So I can say 6 equals x and 15 equals 35. And that's how my proportion is drawn. So now I'm going to cross multiply or use the butterfly effect. And I end up with x equaling 14. So remember to set this up, you would do 15x equal to 6 times 35. When you solve for x, you get x is 14. Okay? And so now I've solved for x. So now let's go ahead and find perimeter. Now remember, perimeter means to add all sides. Or you can always do 2 times the one side and add it to 2 times the other. So I have 6 on this side and 15. And then I have 14 and 35, and make sure you add all sides or multiply by 2. So I have 6 times 2 plus 15 times 2, and I end up with 42. Now I'll do the same thing for the other side, and I should get 98. So I've solved for my perimeters. Now let's see if our scale factors match. So let's do our big one over the top one. So I have 14 over 6. And 14 over 6. And I end up with that long decimal. Make sure you use math, fraction, fraction. End up with 7/3. Now let's check our other ones. I have 35 over 15. So 35 divided by 15. I still end up with 7/3. And then I'm going to check 98 over 42, and you guessed it, I do end up with 7/3. So our perimeters also end up with the same scale factor. Now, for areas is a little different. Remember, we're multiplying for area. Multiply your sides. And you're only multiplying 2 sides. So let's try to do the same example, but now we're going to compare the area. And the area here says it's going to be squared of what the factor is. It's going to be a square version. So if I had this squared, that would be the area. So let's say I had the same figures, but I want to compare the area this time. So I still have 15 and 6, and we saw 4x already, and we said it was 14 and 35. So let's find the area. Make sure you multiply. So make sure you multiply. So I have 6 times 15. 6 times 15 is 90. And then 14 times 35 is 490. And so now we already know that the scale factors for these two was 7/3. So we had 15 over 6 was 7/3. And we had 35. We had 14 over 6, I'm sorry. So 14 over 6 was 7/3, and 35 over 15 was 7/3. So now we're saying that the scale factor should be the squared version. So let me take 490 and divide by 90. I get 49 over 9. But you see the correlation? If I were to take 7/3 and square them, 7 squared is 49, and 3 squared is 9. So this is just a squared version. So area is squared. So you'll see the correlation on the squared factor. So that concludes our notes. If you're to practice on the back side, I'm only assigning 4 problems. So you have 1, 2, 3, and 4. Just note the scale factors on 3 and 4. This is where you're scaling. You're scaling something bigger. So you're going from small to big. So small to big means your scale factor has to be bigger than 1. And if you're going smaller from your big one to your small one, your scale factor is going to be less than 1. It's going to be like a really small fraction, okay? So that concludes our notes. Thank you so much.